In this video, I'm going to talk about Chapter 5, Newton's third law of motion. Let's see. Here. So it's Chapter 5, Newton's third law of motion. What's Newton's third law of motion? Every force is part of interaction. Which means there is always the force, all the force comes in pair. So you have some kind of an interaction, and that interaction comes with the pair of a force. So let's see. I push this note, right? I push the note, and the note pushed back on my hand with the same amount of force in magnitude in the opposite direction. So this pair force always coming in the same magnitude and in the opposite direction. Have a wall, and then I push. Push. And the wall push back. So this is the pair of a force, right? This and this is the pair. Another example is something like you hit the sandbag. Right, so you hit it. Another one, push hard, and the sandbag push back. Push back. Push back. And you see that this pair of force a pair always come in equal in magnitude and opposite direction. All right, so let me just write up a Newton's third law of motion here. Okay, these are the examples. Force always comes in pair. And the Newton's third law of motion says, here is the Newton's third law of motion. Says whenever whenever one object exerts a force on a second object, that second object exerts an equal and opposite force on the first object. So Newton's third law of motion says whenever one object exerts a force on a second object, then the second object always exerts the same in magnitude in the opposite direction onto the first one. So force always come in pair, and this law is also known as a action-reaction law. So it says it's also known as an action-reaction law. To every action, there is always an opposed equal reaction. So it's the same thing as the Newton's third law, just rephrased differently. And the Newton's third law of motion is also called as an action-reaction law. So one thing that I want you to make sure is that you have a pair of a force that's equal in magnitude, always, always. Oh, you cannot have a force by itself. Force always comes in pair. And that pair is, the other pair is the exact same magnitude in the opposite direction. So another example is something like this, right? We use this Newton's third law of motion. And when we walk, we walk on the ground. We walk on the ground and let's see, this is the ground. And what you do to walk, if you want to go forward, your foot exerts a force to the ground in a backward direction. So there is a force. There's a force from there's a force from foot to the ground. You always push it backward. Therefore, the ground exerts the same amount of force, F, from the ground to the foot. this as a friction. So you push the ground backward, ground push you forward in the same amount as you push, right? The amount is equal in magnitude and in the opposite direction. So action force in this case is that you pushing the ground backward, and the reaction force is as a friction force, the ground push you front. So you could never ever have force by itself. You use this action reaction law without thinking. And that force always comes in equal magnitude and opposite direction. So even, let's think about a case for the gravitational force. We have, there's an apple falling. So this apple is in free fall. And then the gravitational force. What is the pair? So you can see the contact force when it's in the contact force, normal force or friction force, you always have a pair. How about non-contact force, right? Like a gravitational force, the field force. Also, force always have to come in pair. So here's the Earth. So the Earth actually is being pulled by the apple, equal in opposite direction. So this is from the Earth to the apple. And then this is the gravitational force from the apple to the Earth. And this force is equal in magnitude in the opposite direction. And these two are pair. Equal in magnitude, opposite direction. All right, the force, even the gravitational force, non-contact force, always have another pair that's equal in magnitude in the opposite direction. So that's what the Newton's third law is. Force always come in pair, and that pair is equal in direction. I want you to see these videos and tell me who is punching the paper harder. So I'm gonna have two of my kids punching the paper. I'm asking them to punch the paper as hard as they can. Okay, so maybe I'm gonna join this game. I'm gonna join this game. I'm gonna punch this paper right now. Okay, let's see. Pretty good, right? So me, who has the authority to give you an extra credit, or my kids, they're going to also punch the paper, and also my husband. He's taller. He might be able to. He has ability to punch the paper hard, but again, I have an authority to give you the extra credit. And tell me from looking at a video, and you saw me punching the paper, who has punched the paper the hardest? So here, I hope you see it. So he's gonna punch the paper. Ignore that he's wearing a girl's shoes. He just does that sometimes. Okay. What is your name?
Girl.
Girl. You're not a girl. Sorry. Let's see. Okay, one more time. What is your name?
Girl.
Girl. You're not a girl. What is your name?
Baby.
Beckett.
Baby.
How old are you now? It's kind of jiggly. 3. Good job. All right. So I want you to punch the paper as hard as you can. The hardest. You're going to punch the paper. Punch it. Okay? Show it to us. You can do it. Harder. Harder. Harder, harder. Yeah. Do it. Okay. Okay, that's your best? Yeah? Okay, thank you. Let's see, it's kind of jiggly, so let me stop sharing and let's go back. Oh, why it's not doing so good. Let's see it. We can start from here. Okay. Okay, let's see.
Baby.
Beckett.
Baby.
How old are you? Good job. Here. All right. So I want you to punch the paper as hard as you can. The hardest. You're going to punch the paper. Punch it. Okay? Show it to us. You can do it. Harder. Harder. Harder, harder. Yeah. Do it. Okay. Okay, that's your best? Yeah? Okay, thank you. All right, and then next video, it's gonna be a little older. She's gonna also try to punch the paper and tell me if she does better job than me. What was your name again?
Avery.
Avery. How old are you now?
5.
5. All right, Avery. Please punch the paper as hard as you can. The hardest. Give it to us. Harder. Harder. Yeah. Yeah. Okay. Okay. Good job. Still jiggly. It's okay. And then here's the one. The guy is gonna hit the paper. Usually, if it's in a class, I'm gonna ask if anybody has taken a boxing class or karate. So they have a skill. You guys would have a probably better skill than me to hit the paper. But I've been doing this enough that I know how to twist it and then give a torque. And that's the best way to to hit it effectively, right? Effectively. So you saw me hitting the paper, and here I'm gonna ask a guy to hit the paper now. So let's see if he can do a better job than me.
Okay.
Okay, hit the paper as hard as you can, please. As hard as you can.
Okay. All right.
All right. Yeah, so what do you say? Do you think I did a better job than him? What do you say? And then we're going to ask you this in a class. Which one you think that did the better job? No, I'm going to tell you this one. The answer is everybody did exert the same amount of force onto the paper. It's 3-year-old, 5-year-old, 1-year-old, a guy, woman, masculine, less masculine, doesn't matter. It's because we're hitting the paper. So I mentioned that force always coming in a pair, equal in magnitude in opposite direction, right? So I can I may have a potential to hit this paper very, very hard, like this. Very, very hard. But how about the paper? What's happening, right? The interaction is that my hand exerting a force onto the paper. Paper is exerting a force back on my hand. Correct. So then, but it's the paper. Paper cannot give any much force back onto my hand. It's just the paper doesn't have that inertia. It can't give the force back. That's why it doesn't hurt hitting a paper, right? So if paper cannot exert a amount of force more than whatever the Newton is, then I cannot exert a force. It can never be more than what it can for the other pair. Pair always comes in the same amount. So no matter how much potential I may have to hit the paper, so I can work out hard to do the best job, to hit the paper the hardest. But since the paper itself cannot give the force back, it can never go any more than what paper is exerting a force onto my hand. It has to be equal in magnitude, right? So the answer is, it doesn't matter. 3 years old, 5 years old, if you a very good professional boxer. That's why when you do practice for the boxing, you don't use the paper to practice, because the paper is, you're not exerting a force. You can exert a force, right? And it doesn't hurt hitting a paper. It's because you can exert a force. You cannot. Paper cannot, so you cannot. Same thing happens when you walk on the ice. You might have a potential to push the ice as hard as you want to, but since ice cannot give a friction, as much friction on you, therefore you can't exert a force onto the ice. Ice cannot exert a force on you. You cannot go forward. So same thing. Force always comes in pair and in an opposite direction. Equal and opposite. Let me not do this one. Let's share this one. Okay. Here. So you see that force always action and reaction forces. One force is called the action force. The other force is called the reaction force. They're co-pairs of a single interaction. Neither force exists without each other. You will never have a force that existing by yourself, and then they're always equal in strength and opposite in direction. And the thing is that always acts on different object. My hand exerts a force onto the paper. Paper exerts a force onto my hand. So I am the action reaction onto my hand. All right. So you always have an interaction between the two objects. So let's look at this thing here. This is how I'm going to end this first video. Okay, so here you have a horse that has a wagon, and we say that all the forces always come in pair, and they're gonna cancel out. Then if it's equal in magnitude and in opposite direction, they should cancel out. But how can a horse pull the wagon? How can a wagon move if all the forces come in pair? How? So I want you to talk about this, discuss. We're going to discuss this in a class. All right, so this is going to be the first part of the video. Bye.